everybody, my name is Allison and I'm with Arizona Science Center, and thank you so much for joining us for our 1 p.m. live demonstration. So today, standing in a dark room with a blue light on. Can anyone take any guesses what we might be talking about today? Well, if you guessed light and color, you would totally be correct, because today we're going to be talking about light and the primary colors of light. So let's start by just asking, what is light? What do you all already know about light? If you know something you want to add, feel free to add that into the comments. What do we know? Well, we know light is going to be that part of the electromagnetic spectrum, or visible light, so to say, is what we are able to see of the electromagnetic spectrum. And when we think about light and that range that we can see, you might think about a rainbow. So when we see light outside, we can see it diffracted into the rainbow. So we know that light is going to be a spectrum of colors. And these different colors of light are different wavelengths of light. And now, how can we see that though? We know light, we know white light is a mixture of all these different colors of light. And we know that visible light is that part of the electromagnetic spectrum, but how do we see it? Well, we have to talk about our eyes for a second. So in our eyes, we have these things called cones. And these cones help us perceive light. So the light is going to bounce off an object and into our eyes, and that's going to help us see. So I can see my hand right now, even though it is kind of dark. I still have light bouncing off my hand and into my eyes, which allow me to see my hand. Now, those cones in our eyes are particularly receptive to the primary colors of light. Now, if you've learned about primary colors, you might be thinking back to an art class, where your art teacher might be saying the primary colors are red, blue, and yellow. Well, art teachers will be talking about pigment. And today, we're going to be talking about light. So those primary colors of light are actually red, blue, and green. So our eyes, those cones in our eyes, are especially receptive to those three colors. So we're going to explore a little bit. So right now, I have a blue light on. You might be able to hear my dogs running around in the background. Sorry guys, working from home. So I have this blue light on, and you can see the blue light is hitting me, but what's behind me? Well, you might say a shadow, and you'd be totally correct, because I'm an opaque object. I'm blocking this light. The light is not able to hit the wall behind me, so we can see a shadow. So let's turn on a red light and see what happens. So now I have two different lights on. So I have a blue light in front of me, and I have a red light slightly off to my side. What do you observe about the shadows behind me now? Well, my body is blocking some of the red light, so you are able to see the blue shadow over here. My body's blocking some blue light, so you can see my red shadow over here. But what about the rest of the wall behind me? When we have the red light and the blue light, or blue light and red light, mixed together, the color that we're going to see is magenta. So it's kind of that purplish color on the wall. So we see magenta behind me. Now let's explore with two different colors. So what if I turn off this blue light? Now I just have a red light on and we can see my shadow. If I were to turn on a green light, what color do you predict you'll be able to see when the red and the green lights mix? What's your prediction? Let's turn on the green light and see if your prediction was correct. What do you notice? So we see the green light blocking it, so you can see my green shadow. Red light blocking it, so you can see my red shadow. But what is this color when they're mixed together? I hope you said yellow. So red and green, when those colors of light mix together, you see yellow. So yellow is going to be one of our secondary colors of light. So let's try our last one. So I'm going to turn off that red light. Oops. Now I have my green light only, so we turn on my blue light again. What do we predict if we put blue and green together? Let's see. So I have, once again, my blue shadow, my green shadow, and then what is that color when they're mixed together? You might say light blue, you might be saying kind of tealish. The name for that color is going to be cyan. So when green light and blue light mix together, you get cyan. So let's turn all three of these lights on and see what happens. So now I have my red light, my blue light, and my green light. And what do you all observe? Get my hair out of the way here. What do you notice about my shadows? What colors do you see? How many colors do you see? You should still see some of my green shadow, where my body is blocking the red and the blue light. And you should see some of my red shadow, where my body is blocking the blue and the green light. But you should also be able to see those colors mixing together. So behind my head, and when I point to it, I actually make more shadows. Behind my head, you can see that yellow color mixing of the red and the green, where my body is blocking only the blue. And you can see the magenta, where the red and the blue are mixing over to this direction. And you can see my cyan over in this direction from where my blue and green are mixing, and my body is blocking the red. So in this area right here, we see the primary colors of light, which are red, blue, and green. And then you're able to see those secondary colors of magenta, yellow, and cyan. Now, the last thing to observe with this is, what do we notice about the wall behind me that has all the colors mixing together? So when all three of those primary colors of light come together, what color is the wall in those other areas? Well, you might say gray or white. To be fair, the wall is painted slightly gray, slightly off-white, so it should be more of that off-white color. But really, when we mix together that red, the blue, and the green, those colors together make white light. Just like when we think about the spectrum of light put together makes white light as well. Our eyes just have those receptors that especially are prone to the red, the blue, and the green. So, thank you all for joining us today as we explored the primary colors of light. Hopefully you all learned something a little bit new today. When we're thinking about primary colors, we have to think differently if we're talking about pigments versus if we're talking about light. And this is something you guys can actually do at home. So if you have a red light, a blue light, and a green light, you can create your own light show. It's kind of fun. You can make shadows and make different shapes. If you have LEDs at home, so like little lights, you can do the same thing with that, or flashlights that you can put cellophane or some sort of clear colored paper over. You can color the surface of a flashlight. So this is something that you guys can explore at home. Try exploring with red, blue, and green and see what you guys get. See if you can put on your own light show. Thank you all again for joining us today. My name is Allison with Arizona Science Center. We have live demonstrations every day at 1 p.m. and more resources on our website at azscience.org. Thank you again. Have a great day.